much. Wow, good evening to all of you. Now, in this session, we are going to see some very interesting chapter, which is called Continuity and Differentiability. So, I have provided you with all the important concepts and all the important numericals connected to continuity and differentiability. I have been telling you repeatedly that inverse trigonometry and trigonometry stands as a base for continuity and differentiability. So, if you before going through continuity and differentiability chapter, it is very much worthwhile for all of you that uh, it is very much worthwhile to all of you to go through the chapter inverse trigonometry again, because it will be a very useful revision, particularly the second exercise under ITF, that is the properties of inverse trigonometric function. So if you can go through that and come back to inverse trigonometry, it will be very useful thing for all of you. And if you want me to teach you differentiation, I'm ready to help you out. I have given my uh, phone number in the description. You can contact me, book for a class, and then we can see all the important concepts under differentiation. So with this, now we go to the session, and all the very best to all of you. So a warm welcome to all of you. Now in this session, we are going to see the concept of continuity and differentiability. So now let us discuss the concept of continuity. It is before we discuss, it is a very surprising chapter that it is the base for the rest of the calculus to come, and it carries very less weightage of only 4 to 5 marks. From the blueprint, you can directly see the blueprint video I have already published. So from that video, you can refer to the uh, weightage of this chapter. This is very less as far as the weightage has to be, but nevertheless, we will see all the important concepts because it is just a base for what is rest of what is about to come. So I thought that I can do it differently this time. I thought of giving you everything because all these concepts are really important for your exam point of view and also for your conceptual understanding. So now let us go into this session. So now we are going to see the concept of continuity and differentiability. First, let us discuss what is continuity at a point. So as I had written here, f of x is said to be continuous if limit of x tends to be a, f of x equal to f of a. I have also given the conditions for when the function is discontinuous. Suppose for example f of a is not defined, that is when infinity comes. Second condition, the value limit of the value doesn't exist. Limit of x tends to be a, this value, I mean this value, limit of f of x tends to be a, f of x equal to f of a, it doesn't exist, then it is not continuous. Or this is not equal, limit of x tends to be a, f of x is not equal to f of a, then also the function is discontinuous function. So now if a function is continuous at x is equal to a, now this is a new concept to you guys. If limit of x tends to be a minus means left hand limit. Suppose we are assuming that a is 0. So 0 minus means towards the left of 0. That is, it is approaching 0. From the left hand side, it is approaching 0. So that is the meaning. So limit of x tends to be a minus f of x. So it is towards the left of 0. That is what I have written as LHL, which is otherwise called left hand limit. So limit of x tends to be a minus f of x equal to limit of x tends to be a plus f of x. Suppose if a we have already assumed it as 0, a plus means towards the right of 0, like 0 0.1, 0 0.2, like that. It has crossed 0. So limit of x tends to be a plus, that is also called right hand limit, f of x equal to f of a. If it is equal, then it is continuous at x is equal to a. Now we are going to see the next important definition for continuous function when in an interval. So f of x is said to be continuous in closed interval a comma b. Intervals, you have to be very specific. Closed interval means a is also included, b is also included, and in between values of a and b are also included. If it is suppose if it is an open interval, then only the in between values of a and b are to be included. So now continuity in an interval, f of x is said to be continuous in closed interval a comma b if it is continuous at each point of a comma b in closed interval. So it is very simple. Now we go to the concept of algebra of continuous functions, which is plus, minus, multiplication and division. So we assume that both the functions are continuous. F of x and g of x are continuous, and f of x plus g of x is continuous at x is equal to c, Second is f of x minus g of x is continuous at x is equal to c. Third is f of x into g of x is continuous at x is equal to c. And fourth is f of x divided by g of x is continuous at x is equal to c, provided when g of x is not equal to 0. So when g of x is not equal to 0, you can say that it is continuous function. If g of x equal to 0, then it becomes infinity, because denominator is 0, so it is not defined overall. So it becomes discontinuous. When g of x is not equal to 0, the function is continuous. So this is about the concept of continuity. Now we go to the concept of differentiability, wherein everything is a formula based. So I have given you all the formulas. I want to give you all these formulas in detail, so that if you can know the formulas, or if you can know how to derive this in your exam, it will be quite useful for you. So I thought that let me give out all the formulas under differentiation. It has got 23, 24 formulas overall. So f of x, f dash of x. First is x power n. That is a simple thing. So differentiation of x power n is nx power n minus 1. You can also derive all these things. If you have any doubts in deriving, if you want separate class in differentiation, you can always contact me. I have provided my number. You can contact me over there, or you can where you can post your queries. If you can also book a class if you want special class. So I am ready to help you out. So now coming back to concept of differentiation, x power n differentiation is nx power n minus 1, sin x differentiation is cos x differentiation is minus sin x, tan x, which is can be written as sin x by cos x, and its differentiation is secant square x, cot x, which can be written as cos x by sin x, so its differentiation is minus cosecant square x, secant x reciprocal of cos 1 by cos, its differentiation is secant x tan x. Cosecant x differentiation is minus cosecant x cot x. Similarly, now with this, trigonometric functions are over. Now we go to the concept of inverse trigonometric functions. Sin inverse x differentiation 1 by root of 1 minus x square. Cos inverse x differentiation minus 1 by root of 1 minus x square. Tan inverse x differentiation 1 by 1 plus x square. Cot inverse x differentiation minus 1 by 1 plus x square. And secant inverse x differentiation 1 by x root of x square minus 1, cosecant inverse x differentiation minus 1 by x root of x square minus 1. You need not be afraid of all these formulas, guys. There are a lot of ways of deriving all these formulas. So if you want me to help you out, if you want a special class on differentiation, you can reach out to my number, book a class, and then we can see. I'll explain all the important derivations, important concepts, and the numericals, everything in detail. So you can all be thorough with this chapter. It is such a simple chapter. Log x differentiation is 1 by x, e power x differentiation is e power x, a power x differentiation is a power x log a. Similarly, if you have got a functions of x, u and v, where u and v are both functions of x, its differentiation is du by dx plus dv by dx. Du by dx can now be written as u dash, dv by dx is can now be written as v dash, or u by u dash plus v dash. Similarly, u minus v's differentiation is du by dx minus dv by dx, where both u and v are functions of x, and du by dx can now be written as u dash, dv by dx can now be written as v dash. Similarly, uv, product rule. First you have to keep the first term as it is, differentiate the second term, and you have to put plus, and retain the second term as it is, differentiate the first term. So it is v du by dx plus u dv by dx. It can also be written in the reverse order, like u dv by dx plus v du by dx, or v u dash plus u v dash. U by v, quotient rule, v du by dx minus u dv by dx whole divided by v square, or v u dash minus u v dash whole divided by v square. So now we will see some simple derivations of some constants, and for x bar something. So constant, differentiation of a constant always gives you 0, and differentiation of x gives you 1. Differentiation of root x can now be written as x bar half, and if you apply the first formula, x bar n's formula, whereby taking n is equal to half, you will be getting this value 1 by 2 root x, and 1 by x, you can write 1 by x as x bar minus 1 and apply x bar n's formula, you will be getting minus 1 by x square. So now next important concept is logarithmic differentiation. I have given you the condition for logarithmic differentiation as well. When the power of x is a variable, that means the power of x should not be a constant. If it is not a constant but a variable connected to x or y or something like that, then you have to compulsorily use logarithmic differentiation. I have given you the rules for it. Log of AB, which is log A plus log B, log of A by B equal to log A minus log B, and log of A power B equal to B log A. The next concept is parametric differentiation, wherein you have to identify the parameter connected to the function. If it is t, then you have to differentiate both x and y with respect to the parameter t, and then you have to find out dy by dx, which is dy by dt whole divided by dx by dt. And you have a special case as well. They may be asking you to differentiate the function with respect to another function. That's what I have written, du by dv. It can be written as du by dx by dv by dx. So the important questions in this chapter, I have given examples 1, 3, 4, 7, 10, 11 and 15 all connected to the first exercise. And in first exercise you have third sum, under third sum you have C and D. Similarly 6, 13, 17, 20, 21, 29 and 30. And some questions connected to the second exercise, example 22 and 23. In exercise 5.2 you have 4 sums, 4, 5, 6, 8. Similarly, in the 5.3 exercise, 5th sum, 8th sum, and from 9 to 15. When I was taking inverse trigonometry, I would have told you this is the base for calculus, so you need to be thorough with all the concepts of inverse trigonometry. So, in exercise 5.3, the questions 9 to 15 are all what we studied in inverse trigonometry. So, you have to remember the properties of ITF to answer these questions. Very, very important. That's why I circled 9 to 15. Any question can be asked from over there. So now after that, example 30 and 32, and in exercise 5.5 you have got 5 questions, 1, 5, 10, 12 and 16. Similarly, example 36 and 37 connected to the 6th exercise. In 6th exercise you have 5, 6, 8, 9, 10 and 11. And example 41, also example 41. Now you have got the last exercise 5.7, wherein you have got 5 sums, 12, 14, 15, 16 and 17. So if you have any doubts in these questions, if you want me to help you out, I am ready to help you out, guys. You can contact me through my number. I have provided my number in the description, wherein you can book an appointment for the class, and then we can see all these concepts in detail. I think it was a very useful session for all of you. Thank you. We'll meet with so many other sessions in the future, and all the very best to you.